Problem 3, solution for Math 251. What we're given here is we're asked to graph these functions. We've given some assumptions that the functions are continuous and differentiable. Basically just means that they're kind of smooth curves. And so we have to graph, and one of them will be impossible. Adds another little curveball into this. So okay, it says, so maybe we should go through and talk about what this means. The first derivative is positive. That means that my function is increasing. And first derivative negative means my function is decreasing. And second derivative negative means my function is concave down. If I go through on these other ones and interpret them, first derivative positive is increasing, negative decreasing. Second derivative positive means concave up. First derivative always positive means it's always increasing. Second derivative positive means concave up. Second derivative negative means concave down. And first derivative positive, again increasing. Second derivative negative means concave down. Second derivative positive means concave up. So I think having that little translation will help us draw these graphs. See, in the first one, we want our first derivative to be positive if x is less than 0. So we're going up on this side of the graph. We're going down on this side of the graph. And it's always concave down. So what that means is that our function looks something like this. It's always concave down. It's going up when x is less than 0, and it's going down when x is greater than 0. All right, the second one, the first derivative. So if you were to try to draw this, okay, it's concave up, so it's kind of shaped like a bowl in this one, this upside down. But it's supposed to be increasing on the left-hand side and decreasing on the right-hand side. So it kind of has to look like this, and then switch to something like this. And the problem is it's not differentiable at this point. What I'm saying is that, differentiable. What I'm saying is up in these assumptions, we said that all functions are continuous and differentiable. They're all smooth turns. You don't have these sharp curves like this. But in order to satisfy all these criteria, we'd have to have a sharp curve right here. So this one is the one that's not possible. Another way you can convince yourself of that is the second derivative is the derivative of the derivative. So the second derivative is always positive. What that means is that our derivative is always getting bigger. Well, if it's always getting bigger, we can't go from a positive number to a negative number. To go from a positive number to a negative number, you have to get smaller. So if the second derivative is positive, it's always getting bigger. We couldn't possibly go from a positive to a negative. So this one is not possible. And that's good news because it'll be easier to find C and D. Now we know these have to exist because it says up here that only one of the 4 are not possible. So in this one, we're always increasing. It's always going up. But our second derivative switches from concave up to concave down when x equals 0. So this one is going to look something kind of hard to draw. We're concave up and increasing, and then we switch. Well, kind of ran out of room, but that's all right. To concave down. Concave up to concave down, but it's always increasing. So maybe your graph looks something like this. And part D is very similar to part C. It's always increasing again, but now it goes from concave down to concave up. Okay, kind of the same idea. We're concave down here, but we're increasing, and then we switch to concave up. But note, we're always increasing. It never gets flat anywhere in there. So I think what we have is all the graphs, or examples of all the graphs, so that's the end of this perfect problem.